So all of our jobs are succeeded and now it is successfully deployed. Now we see our application running, and let's try to change this return message here to hey there and commit this change over here. So now it will detect a change in our main branch. So it is going to run all of our jobs again. All of the jobs are completed without any errors. So that's why we see a green tick here. So now if we just try to reload our application, we see hey there.
So hey everyone, in this video we are going to understand what is CI/CD and how it can help us to automate our deployments. Alright. So far what we have been doing is we have been having our code and we make any changes to this code. What we do is we just push it to like GitHub or Docker Hub. Okay, and based on this we SSH into our EC2 machine. So let's consider this to be our EC2 machine. So what we just do is we follow the steps, like we SSH first into the machine. So we just get inside the container of this, and then there we just do a docker pull. Okay, so this will pull our latest image, and then based on that we just need to run our new container. So we just run new container, and then we just start our server. So we just start our server. So this is a lot of manual work, right? Anytime we make a change, we just need to push it to Docker Hub or GitHub. Okay, and based on that it should be, we just need to go into the container, just pull the image, and then run the new container of that. Okay, so we just need to we can just actually automate this. All right, so whenever we push our code, okay, so anytime like on GitHub or Docker Hub, so it should automatically pull and then it should run a container out there. Okay, so we just want to automate this entire process, right? So whenever a developer pushes the code, so it should actually auto deploy, and then we can just see our latest changes on the wherever you're deployed, for example EC2. All right, so but if any developer comes and pushes some code which has a lot of bugs, all right, so at that point of time nobody would want to see a website with a lot of bugs, right? So we need to include testing. So within our backend project we had already implemented testing such that by the run of a command all of our tests will actually pass or not. Whether if it passes, then it will proceed, otherwise it will fail. So we just want to do something like that. If all of our tests pass, only then do we actually push our code to GitHub. So that's also a part of CI/CD which we will be implementing. So basically CI/CD is nothing but continuous integration and continuous delivery or deployment. All right, so that's what we are going to understand in this video. So when it comes to CI, okay, basically it should successfully build. All right, so build our application such that we can deploy that. So this is the process where we run all of our tests, and then we need to ensure that we are successfully building this without any errors. Okay, so build successfully. So this step ensures that if anyone pushes the code, it should make sure that it passes all the tests and it should build successfully, all right, without any errors. So that is where the integration part gets succeeded. Okay, so the next step is deployment. Okay, so that is CD, which is also stands for continuous deployment. So over here the code gets automatically deployed without our human intervention, because without even us just going to check whether our application is deployed or not and stuff. Okay, so over here we say automate deployment. So now we have understood what CI/CD is, but how can we implement? Okay, so currently if you remember, we are currently using GitHub, right, where we have actually been maintaining our code. So in GitHub we have something called as actions. Okay, so we can just call this GitHub Actions. And basically what this does is, within our local file we just need to write a workflow file. Okay, whenever we as a developer push some changes into a, let's say, main branch. Okay, so whenever we push to a main branch, some jobs should actually run. Okay, so basically these jobs are nothing but steps, okay, which all it should follow. Like first thing is it has to check out the code. Basically it has to take the pull from GitHub, and then it should run all of our tests and they should actually pass. And then we just need to log into our SSH machine, and then we need to pull the image from Docker Hub or GitHub, and then based on that it has to start a new container and start the service. Okay, so all of these steps we write in the form of something called as jobs. Okay, so basically we have just done this for main branch. So you might be having another branch, like let's say pre-prod branch or a development branch. So based on that we have different workflow files. It's not just limited to one particular branch. Okay, so you can write multiple actions as well. So currently we are just going to focus on main branch branch, such that if we push any code to our main branch, so it should detect the changes and it should run all of these jobs. Okay, so one is testing, one is logging into our EC2, like taking the pull and then starting a new container and deploying our changes. All right, so basically this is a pipeline. All right, so one by one it runs all the jobs. All right, so that's why it's called as a CI/CD pipeline. So I hope you got to know the entire workflow, how CI/CD actually works. So basically, when we have our local code, whenever we push our changes to, let's say, GitHub, so we are using GitHub Actions, right? So here we just need to push it to GitHub, and then inside our EC2 it just needs to take the pull. It will run all the actual jobs. So if it succeeds, then within GitHub Actions you'll get a green flag or a red flag. Okay, so if it is a green flag, that means that it has successfully ran all of your jobs without any errors. All right, so if there is any error, it will just show a error or a cross mark saying that there's something went wrong. Okay, so that's where you can just actually check if our actual changes has been deployed or not. Okay, so now let us go ahead and implement CI/CD for our backend to-do application so far, which we have been doing in this entire series. And over there we are just going to follow the Docker approach, where we are using Docker to deploy our containers to EC2, because this is the standard approach. Whenever we are deploying backends, we just don't deploy it nakedly, so we just always use something like containerization. So that is why I'm just going to follow this particular approach and just show you how using Docker we can automate all of our deployments. All right, so let's get started.
So this is the repository which we have been working so far. Okay, so we want to implement CI/CD such that if I make any commit, it should deploy to AWS. Okay, using the Docker approach. Okay, so basically we had already created a video, so where we had deployed our application to AWS using Docker, basically on ECS, okay, Elastic Container Service, which will do all of the orchestration work for us. So we are just going to follow the same approach. So these are the things which we need to set up in AWS before we actually deploy it. Okay, we need to create a IAM user, which we can retrieve the secret access key and also the credentials key. So using that, we need to actually log in through that user where we are actually deploying, and then we need to also have a registry to store our Docker containers, and also a service, okay, inside ECS, so where our actual task is actually running. So all of that steps we need to set up, which I have also displayed over here. So let us quickly go ahead and do that setup. So I'm just going to AWS console. So if you don't have an account, you can just go ahead and create one. So we can just click on sign in to console. So of course this will actually require you to enter your credit card. Okay, so in order to create an account, so I already have one, so we can just I'm just going to sign in through my email ID. So once you sign in, the first step, as I told, is to create a user and retrieve those two keys. That so we can just click on IAM, or you can also search from here. So you can just search for IAM, and over here we can just create a user. Okay, so if you are the root user, I guess you will be having the permissions to actually create a user. So if I click on users, so I already have a user. Okay, so if I want another one, I can just click on create user. So let's create a user called as test user. Okay, and we can just click on attach policies directly, and we can just give this administrator policy, just which means that this user has all the access. Okay, so based on your real project that you're building, and of course the actual application, we always of course need to restrict some policies. Okay, so I'm just going to give this administrator access and click on next, and we can just review this and click on create user. Okay, so this will go ahead and create a user. So once the user is created, so we can just click on this, and here you can see a button over here to create an access key. So you can just click on this, and here we can just select command line interface, because we want to operate using those credentials through the CLI. So we can just click on I understand and click on next. So over here you have two keys, one is your access key and one is your secret access key. Okay, so make sure you keep the secret access key in some safe place, because once I click on done, so this will not be shown again. Okay, so once I just copy this and paste it somewhere. So once you have done that, you can just click on done. Okay, so as it says, if you haven't copied your secret key, you cannot retrieve this in the future. Again, you have to create a new user. So you can just click on continue once you have done that. So the next step is to create a registry for storing our Docker images. So you can just go to ECR, which stands for Elastic Container Registry. So I have already explained you in the previous video how to actually set it up. So you can just refer that video for some more details if you want. So I'm just going to call this to do backend. all right, and I'm just going to click on create. So now we just do not want to push our Docker image to this particular repository. Okay, so this is the job of the CI/CD to do by itself. All right, so we just want to automate this entire process. So we just want to leave this empty as is. Okay, so this repository doesn't contain any images. All right, so once we have created a repository, so we can now go ahead and create a task inside ECS. Okay, so let's go to ECS. So this is the third step, by the way, and we can now go ahead and create a cluster first in order to create a task. So let's click on get started. Currently I don't have any clusters, so let's click on this. So let's give this a name of to do app cluster, and let's use Fargate, which is serverless, and let's click on create. Okay, so once our clusters are created, again we don't do anything, so we just want to create and just copy the name of the cluster. All of this will be taken care inside the workflow file that we write. All right, so now we can go ahead and create a task definition. So I'm just going to click on create new task definition. So here let's give a name of to do app task definition. Again we choose AWS Fargate. Okay, and we can just leave this by default, because this is just for test deployment and we are not doing actual deployment. Later, after we explore CI/CD, we are going to delete all of this. So we can just choose Linux x86. Okay, so which is the default, and one CPU is fine. And here for this containers, it actually doesn't matter, so you can just give this any name. So I'm just going to call this to do app, and I'm just going to give this a random image URI, which I had already built in the previous video. So now let's give this port mapping, so which will target the internal container port of 8080, and this will run on TCP. Okay, so rest of the things we can just leave it as is. So now we can just click on create. Okay, so this will go ahead and create a task for us. So the fourth step right now is to create a service. Okay, so inside our cluster we can just click on a cluster and click on create service. Currently we do not have any service, so let's click on service. So basically this is the task that I just created, so we just need to select a task before we actually create a service. So this is the revision. So currently it is, for you it might be 1, because since I was testing it previously it is showing 7. We can just give the service name as to do app service. So we are not interested in all this stuff, which you should actually explore when you're deploying a real application. Okay, so I'm just going to choose a load balancer, which I can just click on this and try to create a load balancer, which is a new one. So I'm just going to call this to do app load balancer, and I'm just going to listen this on port 8080, which is the actual port our application is running. So the target port is also 8080, which runs on HTTP. All right, so let's give this of 8080, and yeah, that's it. Let's now go ahead and click on create. So now it says to do app service deployment is in progress. So of course this is going to fail, because we just want to create a service task and this particular cluster in order to use within our CI/CD workflow. Okay, so of course this is going to fail, so you just don't have to bother about it. So now finally we have completed these particular steps in order to implement CI/CD for this particular project. All right, so now it's the time to write the workflow file. All right, so currently GitHub always finds for a particular name, okay, called as .github. Okay, so if it finds that folder here, so that will go ahead and get managed, okay, by this particular actions. Okay, so currently if you just click on this, it will just give us some instructions. So this will not be actual GitHub actions. So if you don't have the .github folder, all right, so if it finds that workflow file, then we can just go ahead and track our CI/CD through this actions tab, which I'll come shortly. All right, so let's now go ahead and create that workflow file. Let's now create that folder called as .github. Okay, make sure you spell this right, and inside this we need to create another folder called as workflows. Okay, and over here we need to write the workflow file in the form of a YAML format. Okay, so as I told you, YAML is similar to JSON, but we just use indentation. So I've already explained that. So we can just call this AWS workflow .yaml, or maybe AWS deploy, which sounds sense. Okay, so over here we need to write our steps. All right, so one thing, as I told you, we need to first run our tests. If it passes, only then do we deploy this. All right, so let's get started with the first thing. So the first step is, as I told you, we can create multiple workflow files, right? So this is one such workflow file. So we just need to give this a unique name. All right, so we can just give this a name of like, let's say, deploy to AWS. All right, so now we just want to trigger this exact workflow file whenever there is some action that is done on this particular repository. So what is that particular action? Just as I told you, when somebody pushes on the main branch, okay, so we just want to trigger this workflow file. So we can just mention on, and inside this on, just if I just give two spaces, which means that it is inside this block. So that's how YAML is actually written. So we can just say on push and then branches, and inside branches we need to give this a list. So currently we just have one, so that is main. Okay, so make sure you spell all of these right, otherwise it will not run. So which means that on whenever we push anything on this main branch, this workflow should actually run. All right, so this is the first step, and the next step is to specify all of your environment variables on the top level. Okay, so currently we have specified the names, right, whichever the name that we have given inside our AWS cluster. So if I can just show you that. So this is, I have named this as to do app cluster. So this is a name. So for this task definition, I have called this to do app task definition, and for the ECR registry, I have called it to do app backend, right? So all of the names we just need to store within our environment variables. So you can just say env right here, and over here we just need to specify all the environment variables. So which I'm just going to paste this right here. So over here I have just pasted all the environment variables that are actually required to write our workflow. So one is the AWS region. So basically whenever you're creating any service over here, we always need to specify the region, right? So currently I've selected the Mumbai region, where the code is AP South 1. So that's what I have specified over here. And this is the ECR repository. What is the exact repository name I have given for my for storing Docker containers. So, and then this is the ECS cluster, which I have named as to do app cluster, and the service to do app service, and then the task definition. Okay, so you need to verify that all of these names are correct. If not, you will get an error. All right, so the next step is to write our jobs. Okay, so currently we are having two jobs. One is for the testing. So once our testing is complete, and then we actually do the deployment phase. Okay, so we just say jobs over here, and inside this jobs we need to specify the name of our job. So let's call this test, and inside this test we need to specify the environment where this actual test should actually run on. Okay, so let's specify runs on, which is something like this, and here we just need to select the actual operating system, basically Ubuntu latest. So this is basically provided by GitHub itself, which will actually start a virtual machine internally. And once we have defined our environment, we need to specify the steps. Okay, so basically this will have certain steps, okay, where we need to give this a name and what exactly it does. Okay, so this will actually take in a list. So this is actually called as the pipeline. So that is why it's called as a GitHub pipeline, sorry, CI/CD pipeline. So all of these steps will run sequentially. All right, so one after the other. So what is the first step? We just need to check out our code. Basically we just need to clone the code and then run all of our tests. Okay, only if they pass does it go to the next job, right? So let's give this a name of checkout code first. So all right, and here we can just specify uses. So basically the main purpose of writing this GitHub workflow is, so there is already pre-built methods that is been defined by some other developers, which we can actually reuse within our workflow file. Okay, so we just don't have to repeat ourselves by just writing it ourselves manually. So there is already a pre-built action, basically an automation script that is already be available on GitHub. Instead of writing all the checkout commands, we can just reuse that. All right, so we can just if you want, you can just refer the documentation on how exactly we can use this. So the exact action name is actions/checkout @v3. basically this is the latest version, okay, of that pre-built script. And once this is done, we need to now install pnpm, right, because that's the package manager which we are using for this particular project. So in any case, if you are using npm also, we also need to install that. So since we are using pnpm, I'm just going to give this another step called as install pnpm. All right, and let's again specify the uses. So basically this has a pre-built action called as pnpm slash action slash dash setup at the rate v2. Okay, so again this all I actually don't know, so I have referred the documentation and only then I'm actually using this, so you too must do the same. Okay, so once this is done, we also need to specify width, okay, over here, and we need to specify the version, and this runs on version 8, and we need to also specify another thing, that is run install, and set this to false. Okay, so basically what this does is, whenever we are wanting to auto install dependencies, so we just do on that, so we set this to false. All right, so now we can just go to the next step, so that is to set up nodejs. Okay, so we can just give this a name of setup nodejs, because this any fresh Ubuntu machine that you start will have nothing inside it, okay, except git. So we just need to also install nodejs, so setup nodejs, and let's again give this a uses. Okay, so there are a lot of pre-built methods which you can actually explore, so which you can actually reuse within your workflow file. So we can just specify this to be actions slash setup node, and give this a version of v3, and then we need to specify the version again. So for that we say width, and then specify node version, and we just give this 20. Okay, and then we now need to specify cache. So basically we are using pnpm, right? So we can just specify pnpm. So basically this will actually enable dependency caching. Okay, so in order to make our installation faster, right? So we can also specify the dependency path, that is pnpm log.yaml, right? So this exact file right here, pnpm log. So we can say cache dependency path and set this to pnpm log.yaml, and the next step is to install all the dependencies and then run all of our tests. Okay, so let's give this a name of install dependencies. So in order to run a specific command, we use the run keyword. Okay, so this will run the command, so that is pnpm install. Okay, so this will install all the dependencies, and once they are installed, so as I told, this is a pipeline, this will run sequentially. Once this is installed, we just need to run all of our tests, so we can just give this a name, run tests. Okay, and then we just want to run the command, that is pnpm test. Alright, so this refers to this exact file right here, so sorry, this exact script which we have defined within our package.json. So this will run the vtest. Okay, so now we can just go ahead and write our second job, that is to deploy. So we have completed our first job, that is for testing. Now we just want to run the second job. Okay, so which will actually depend on this previous job, that is test. All right, so let's call this job deploy. Okay, so we can just give this any name that is suitable, and this we can specify needs. Okay, so which means that it depends on this exact result of this particular job, that is test. So if it passes, then it goes ahead and executes this particular job. If not, it fails. Okay, so the entire workflow itself will fail. So we can just say needs test, this exact job name, and now we just need to again specify the environment which it has to run on. So that is Ubuntu latest, which I can just copy paste right here, and now we just need to specify all the AWS stuff which we need to run one by one. Okay, so that is one thing is to log in, and then we need to like push our Docker image to the registry and then run a task, okay, inside ECS, so the service. So we can now do this step by step. So we can just first give the steps. So inside steps, we can again specify the checkout code which will clone our repository. Alright, so make sure the indentation is right, and the next step is we need to configure our AWS credentials, basically using the AWS CLI. Okay, again we just don't have to specify every single command. So far we have done right using the AWS CLI, that is once we log in, then we actually use the CLI of AWS and then run tasks. So all of that steps is already written in a workflow file which we actually need to reuse that. So we can just give this a name of, like, let's say configure AWS credentials, and over here we say uses, and we need to specify the exact pre-built script name. So this is the script name. So in case you don't know the exact names, as I told you can just Google this. So we can just say configure AWS credentials, GitHub Actions. So it actually you can just go here, and this is the exact script, okay, which will actually run. So if I'm not wrong, this should be a name. So if you just keep scrolling, there should be a exact name over here. So it's right here, AWS Actions, configure AWS credentials and give this a version. Okay, so that's exactly where I actually got this. So after that, we need to specify these things right here, that is the region and stuff. So we just need to go here and specify width. Okay, so over here we need to give that access key, secret access key, and then the region. Okay, so all of these comes from our environment variables that I have already specified here. But you might have a question, aren't we exposing all of our env secrets over here? But these are fine, because these are just the names of our services that we have used in AWS, right? So only thing that we don't have to leak is the access key and then the secret access key, right? So that is where we need to use the secrets, GitHub secrets. Okay, so if we go back to our repository, so right here, so we just need to configure our secret. So within our repository, you can just go to settings, and inside settings you should find an option right here called as secrets. Okay, so secrets and variables, and over here you can just click on actions. So once you click on actions, you can click on new repository secret and give this name of your secret, and then paste in your secret value. Okay, so we copied the secret access key and the access key ID, right? So we just need to create those two secrets. So I have already created during testing. So over here, AWS access key ID, and this is the two names. Okay, so I already provided the value for that. So you too can create that, and we can just use that within our workflow file. Okay, so these are the three secrets which we need to provide. So this is the actual key, so AWS access key ID, and this comes with $, 2 curly braces, which is actually used as a dynamic expression. So we say secrets.aws access key ID. So this is the exact name over here that I have specified. So this will refer from our secrets. Okay, so from whichever the account you are actually using this. So if you're using different account, it will use different credentials. So we need to make sure that we are always logged in from our same account. So this is the secret access key, and this is the region. Okay, so this is coming from env.aws region, which we have already specified here. So if you want, you can just go ahead and install this extension for GitHub Actions. So we can just install this. So this will give us some IntelliSense over here, so just like this. So that's the reason why you can actually install this. So once after you have done that, we now need to write our next step, that is to build and push our backend image. Okay, so we can just give this a name. So I've just given this a name of build and push backend image. So within the env, we need to specify ECR_registry and give the registry name. So that is, again, this is a dynamic expression. So we say steps.login-ecr.outputs.registry. Okay, again, you can just refer the documentation by googling it. And once we have done that, we just want to run these commands. So one is to build our image. So this is again a dynamic expression which is coming from the ECR registry, and we are actually tagging it with the commit SHA, so secure hashing algorithm, just to give it a unique tag. Okay, once we have built it, we now need to push it to our Docker registry. Okay, so again by doing the same thing. So this is the same tag. Okay, so this will push our Docker image to ECR, which we actually created using the name to do backend. So this exact name. So once we have done that, we can now move to our next step. So the next step is to download the task definition. Okay, so basically this will be in the form of a JSON file which we need to download and update in our ECS service. So basically these are all the standard way of deploying implementing CI/CD. So you can actually find this within Stack Overflow or generate through ChatGPT or Cursor. So this will actually generate you. And so I've just written them all down in order to avoid any kind of boring typing. So this is the task definition, which is the next step which we need to do, download task definition. So this is the actual command which we need to run. So AWS ECS describe task definition, which we are passing the name of our task definition, and the query which we want to run is this task definition.json. So once it downloads, so we just need to feed that to the ECS, right? So we just want to run another task just for that, calling update ECS task definition. So this is the ID task def, and this uses the pre-built image, so pre-built script AWS actions slash AWS ECS render task definition at version 1, and we just need to pass in the task definition which we had actually downloaded. This is the container name to do app which we actually specified, and then this is the image. Okay, first thing is the ECR registry, and then slash our repository name, and then the GitHub SHA, which is the unique tag that we actually used. Okay, so if you actually downloaded the extension, right, so if you just hover on this, anything which you don't understand, you will understand everything, right? So this will if you just hover on that, it will give us a description on that. All right, so this is one good thing about that extension in case you're finding it difficult to understand. So the next final step is to deploy to Amazon ECS. So basically this also uses a pre-built script over here, that is Amazon ECS deploy task definition at v1. So here we need to specify all the specifications. So that is the task definition, our service where it is running. So this is again coming from our environment variables right here, and then we need to give this service the cluster which we want to deploy, and wait for service stability, which we want to give this to true, which means that the workflow will actually wait till the ECS will confirm if our actual service is stable or not. Okay, so yeah, this is a complete standard. If you want to in case in future want to deploy any project on AWS ECS, okay, so you can just use this as a template and deploy them. All right, so this is the workflow file. So what we just need to do is we just need to push this to GitHub by making a commit. So I'm just going to commit all of these changes. Okay, so if you just go to your source control here, and I'm not able to see anything. My bad, this has to come outside on the root level, so this has gone inside some other folder. So once this is in the root directory where our AWS deploy YAML file is there, we can now go ahead and commit this. So we can just stage all of our changes and give this a message saying CI/CD. And once we have pushed this to GitHub, so we should be able to see our actions running. Okay, so let's go ahead and verify that. So let's go here and can go to our code. So here if you just click on actions, so here you will see all of your previous jobs, okay, based on every commit that you have. So these are all the jobs that will be running. So basically these are all the commits which you can feel free to ignore all of this, because I was just testing it. So if you are doing it for the first time, you will only see this particular commit name, and this is the jobs that will be running. All right, so if you just click on this, you can just see exactly what is happening. So currently it is failed for some reason. So the reason why this is running is it found this folder .github, and inside that it has a folder called workflows, and where exactly our YAML file is actually existing. Okay, so this AWS deploy.yaml. So whenever we push whenever we make any commit on this main branch, this exact file will run, which is containing of two jobs. One is for testing and one is for deployment. So we don't have to manually go to this actions and manually run this file. So this will do it automatically. Okay, so now you see that for it has failed for some reason. So I told you, right, it gives a green flag or a red flag. So currently it's giving red flag because there was some error. Okay, so let us check what is the error. So over here during running the tests, so it is failing somewhere here. So if we just check the logs, it is failing in this particular test, that is run tests. Okay, so if we just have a look at our code, so we have actually given this a step called as run tests, right? So this is the exact step over here. So all the previous steps actually succeeded. If you want, you can also check the logs over there. So this actually checked out the code. So it will clone the code, so it will install pnpm, it will set up nodejs. So all of this actually succeeded. Okay, so if there was any error here, it will just stop here, and this will actually give us a red flag saying that something went wrong. Okay, so the error came something from here. So the reason is that I just misspelled this node version. So instead of n, I just typed a m. So we can now save this, and now if we just make a commit to this, so we can just say fix typo. Okay, and push this code. So now when we try to go back and just try to check the code, and over here you see that another action started to run. Okay, another it is going to try again since we pushed the code, okay, to the main branch. If we push it to some other branch, it will not work, okay. So this job will not run. Since we specified we need, whenever there's a push on the main branch, this job should run, okay. So now you see that all of our tests, it failed again for some reason. So let us debug what is the issue. So I forgot to include the node env set to test, so that was the reason it was failing. So I just made the changes and pushed the code. So now all of our tests are currently passing, and now you see that if on the left side we have two jobs, so one is the test and one is deploy. So the test job is successfully completed, so you see a green tick here, and in the deploy step there is some error, okay. So if you just have a look over here, so you see that it's giving me some invalid reference format. So the reason why it was failing is I forgot this step right here, basically to logging into Amazon ECR, okay. So this is the exact script that is actually used to in order to log in based on these credentials that you actually pass in. So sorry for this, I actually forgot this step. So now let us go ahead and save this and give this a deploy. Okay, so now rerunning my jobs, okay. So it starts from the test. So now it's checking out the code, installing pnpm, setting up nodejs, installing all the dependencies. You see that now the test job is completed. Now it will start the deploy, okay. So now it's logging into ECR. So now it is successful. Previously it was giving me error because of that missing step, okay. So let's wait for everything. So now our image is built, so now it will push our image to ECR, okay. So it is now pushing it. So now it is downloading the task definition, and now it updates the ECS. So okay, so there's some error here, failed to register task definition in ECS, unexpected key, enable fault injection. So I know what the issue is. So if we just go to ECS, and over here we had set up a task, right? So this particular task, so if we just have a look at the JSON, so if we just create a new revision, so we have here a field called as enable fault injection. So by default it is false, so we just don't need this thing actually. So we can just get rid of that and just make a revision here. So we can just click on create new revision, and now we can just rerun our task, okay. So we can now go here and rerun jobs, so rerun all jobs, okay. Or we can specify just the jobs that are actually failed, okay. So the test is passed, so it might only just run deploy. So we can just say rerun jobs, connection interrupted, okay. So this time it is deploying this exact job, okay. So let's wait for it. Okay, so now it has successfully updated our task definition. Previously it had given us the error because of that. So now it is finally deploying to Amazon ECS. Alright, so all of our jobs are succeeded, and now it is successfully deployed, okay. So you see that both of our jobs are completed. So now our application is deployed. So anytime we make a change, it will now automatically deploy. Alright, so now when we go back to our main page over here, so now you will find a green tick over here, which means that it is successfully deployed. It has successfully ran all of our jobs without any errors. All right, so that's a good thing. So now we can just verify by going to our ECS cluster, and you see that there is one specific task that is running, okay. So over here you see that our tasks are running, and if we just have a look at the load balancer that we had just connected. So this is our load balancer which we actually configured. So when we try to look at the DNS record of this and try to access this where our port is running on 8080, so now we see our application running. All right, so now if we just try to make any change, okay, so let's say within my code, if I go to my index.js and let's try to change this return message here to hey there. Alright, so now if I just save this and commit this change over here, So we can just say test change commit sync our changes. So now it will detect a change in our main branch and it will run those two jobs again. So now if we just give this a refresh, so now you see that it's in the currently in pending state. So if we just click on details, so it is going to run all of our jobs again. So let's wait till everything completes. So now all of the jobs are completed without any errors, so that's why we see a green tick here saying success. And for this latest commit test change, okay, so now if we just try to reload our application, we see hey there. Okay, so yeah, this is all about CI/CD, guys. So I hope you have understood how exactly you can automate your deployments such that for any commit that you make, it has to automatically deploy without all of our human intervention. It wastes a lot of our time and resources, so we have automated that using CI/CD, using GitHub Actions. All right, so that is it for this particular video. So if you have any questions, please let me know in the comments. So that is it for this video. Thank you so much for watching. Make sure you subscribe and I'll see you guys in the next video.